Thank you all for holding for today's conference. As a reminder, I would like to inform all participants that your lines will be on a listen-only mode until the question and answer session of today's conference. Today's call is also being recorded. If anyone has any objections, you may disconnect at this time. Please continue to stand by and the call will begin shortly. Thank you.
I just said that was the screw up. And it was like,
All right. Good afternoon, everybody. I'm NASA's Gary Jordan. Thank you for joining us remotely for today's teleconference. Today we have representatives from NASA and Boeing to provide an update on NASA's Boeing crew flight test. Joining our panel today is Mark Nappy, Vice President and Program Manager for the Starliner spacecraft at Boeing, Steve Stitch, Manager of NASA's Commercial Crew Program, and Joel Montalbano, Manager of the International Space Station Program at NASA. We'll first start with some opening remarks from each of our briefers before taking questions. Questions will come in on the phone bridge. Please press *1 to add your name to our queue and to ask a question. With that, we'll now begin with initial remarks from Mark Nappy. Go ahead, Mark.
All right, good afternoon, and thanks for joining us this afternoon. We wanted to provide an update for our CFT launch readiness. We've had some reviews as of late and a couple of things that broke as new issues, so we wanted to provide an update to those. Last Thursday, we had what was called a checkpoint review, and it was a review to review all of our engineering products, where our open issues were as far as closing, et cetera. And going into that review, all of our planned work, everything that we had identified was really in good shape to close for the mission, which we had planned for the July 21st. However, we did have two new issues that cropped up as part of our normal review process, and they were really only a couple of days old, so we really couldn't talk them at any level of detail other than the fact that we had these two issues. So we've spent the last week really looking at those in more detail. I'll give you just a real high-level overview of what those issues are and where we've come to with those. The first issue has to do with our parachute system. In the system, we have the lines that go up from the vehicle to the chutes themselves. There's these small sections of those lines called soft links made of fabric, and they were tested recently because of a discovery that we found during the review process where we believed that the data was recorded incorrectly and we possibly had a lower failure load limit than we previously had understood. We tested those, and sure enough, they did fail at the lower limit, and that ended up decreasing our factor of safety in this soft link pretty significantly. So the issue was found, it was tested, it was validated, and really what we needed to go work on was, is there any recovery from this? The second issue that, again, was discovered very late, a couple of days old, we wrap our wire harnesses with tape so that it protects the wire harnesses from any scuffs or chafing, and that, of course, would provide an opportunity for a short. That tape was tested late in the process, and it was determined to be flammable. There's some ambiguity in the specifications on the use of that tape. Regardless, we have used it quite extensively on Starliner, and so we needed to address the fact that tape is flammable, and we needed to do the proper due diligence to understand it and understand if there's any work that needed to be done in order to provide flight rationale. So over the last week, we've been working to understand these issues, to bound them. We've run several tests. We've gone over in detail all the analysis for both systems to see if there was conservatism in the system or there were tests that we could run to make the results a little bit better. And was it something that would result in flight rationale, an acceptable risk, or was it something that was going to require some modifications or further work? This reached the top levels of Boeing, all the way up to our CEO of Boeing. And Boeing unanimously decided that this was something that we needed to correct. We needed to get closer or to the specifications that was outlined, and we've decided to stand down the preparation for the CFT mission in order to correct these problems. Today was all about communications. This has happened very quickly, and we had the checkpoint review last Thursday. The problems were days old, and so we did our due diligence to understand them and come to a conclusion. This morning, I talked with my boss, and we decided we were standing down. So we spent today notifying NASA and making sure they understood why we were doing. There's been tremendous support from NASA and the crew. Spoke with the crew as well. We notified our management inside of commercial crew on the NASA side and the Boeing side, and then we had a joint all hands today. So today was all about communications, and tomorrow is going to start with the teams on the plans forward. What do we do now that we are going to refocus on modification and minimizing this risk? So we've created some flow charts for the tape. We've created some flow charts for the parachute system, and what is it that we need to go do? We have to go answer all those questions, and then we'll spend the next 5 or 7 days or so answering those questions and putting together schedules that support the recovery and the eventual next attempt for CFT. The vehicle itself is in good shape. We've got it mated, and we were ready for prop load. That was going to happen in mid-month. So we'll stand down on that and then determine how much of the vehicle needs to be disassembled, if any, in order to address these issues. The engineering products, the cert products, we're going to complete those. We had a good line of sight of getting those done this month, and we'll continue with that, and I don't see any issues with getting those done. The mission operations and the simulations, we just finished a big mission simulation this morning. It was a 30-hour simulation, and the team had performed really well, and the results from the sim were really well. So we'll continue doing those to keep the team sharp. And then we have done quite a bit of testing on our flight software, hardware integration, and we'll be wrapping that up with our confidence that that system is ready to go. So really, our focus is going to be on the chute soft link plan, our tape flammability plan. We did have a valve that failed while we were getting ready for our prop load and loading the golden coolant into the system. We removed that valve, replaced it, sent it up to the supplier for teardown, test, and evaluation. We'll work that to understand what the failure mode was and make sure that that doesn't stretch across any other valves on the vehicle. We'll look at any time life cycle type of hardware expirations that may happen, because that'll drive work. And then, of course, there's retest and inspections that we'll have to do depending on the work that we end up going to do. So that's all work that's in front of us, and the teams are really focused on now getting that all understood and defined so that we can take the next steps forward. As far as PCM goes, PCM1, we'll be looking at being able to try to keep that on track. Some of this is really going to provide us an opportunity to get ahead work. The team was going to be very focused in June and July on the mission, and so now we'll just refocus them on PCM1 and try to do some get ahead work to keep that on plan. But we'll do the assessment on that as well and get that all ready to go. So bottom line here, safety is always our top priority. It's always been that way with human space flight, and so that drives this decision. And you could say we're disappointed because it means a delay, but the team's proud that we're making the right choices. So again, we spent today talking to NASA, the crew, the workforce. They've all been informed, and they all stand behind this decision, and we are just looking forward. So with that, I'll turn it over to Steve.
Yeah, thanks, Mark, and I would like to thank all the reporters who are interested in joining us today. And I really want to start off thanking Mark and the Boeing team for coming us to today with the decision to push out the CFT date due to the P213 tape issue and also the soft link on the parachutes. I also want to say how proud I am of the NASA and Boeing team. When we had our review, we had this joint review last week for CFT readiness, and we were really on a good path to get to CFT. We had closed all the IFAs, in-flight anomalies from the OFT-2 mission. We had all the hazard reports completed. We had completed a significant amount of testing and really didn't have any testing remaining on the flight software, including the backup control mode. As Mark said, the vehicle was in great shape. The crew module was ready for cargo load, and really the next big step, as Mark alluded to, was loading prop on the service module. And when we stepped back jointly on the two topics that Mark mentioned, we just didn't think we could get there before propellant load, and we really had a pretty small window here in July to go execute the CFT, the crewed flight test, and so, applaud Mark for deciding to stand down, and we support that decision 100% at NASA. All the NASA leadership has been notified up through the administrator and supports the Boeing decision to step back and go look at the tape issue and also look at the joint on the parachutes and see what the next steps are. I would say it's going to take us a little time to go figure out that path. When you have problems like this, the first thing you try to do is go see if there's a way to get flight rationale with the systems as is. And in this case, it took the team about a week or so to do that. And so we decided today to sit down and talk to you as soon as we had gone through that path and had figured out that that wasn't the right path to get to a crewed flight test in July. Mark and I had an all hands with the entire Boeing NASA team. I would say everybody is a bit disappointed because if you are in human space flight, everybody on the Boeing and NASA team has the jobs they have because they love what they do and they know how important it is for our country to put humans in space and how hard it is. And so there's a little disappointment, but you could see people ready to roll up their sleeves and go figure out what the next steps are, and this team will solve these problems and we'll go fly when we're ready. We also had the crew on today, as Mark said, and Sunny Williams was representing the crew, and she voiced that she and the crew are 100% behind the decision. They understand that the team has crew safety first and foremost in their minds, and they'll fly. They're ready to go fly from a perspective of being trained, but they'll fly when the vehicle's ready to go fly. And with that, I'll turn it over to Joel Montalbano, the ISIS program manager.
Hey, thank you, Steve, and thank you, Mark, and thank you, everybody, for joining us today. The ISIS program has been in regular communication with the commercial crew program as well as our Boeing colleagues, and we've been following all the preparations and making sure ISS is ready when the CFT mission is ready. So as Mark said, it won't be in July, but as the team goes off and looks at the forward plan, the ISS team is ready to support the mission. This is a priority of the ISS program and of the agency, right, and of human spaceflight. It's important to get two commercial crew providers to the International Space Station, and we will fully support the Boeing team and the commercial crew program. Looking forward on ISS, it continues to be busy, right? We had a nice Axiom 2 landing this past Tuesday evening. The mission really went well for us. While we have lessons learned like we do on all missions, nothing really critical, and huge success from both the NASA side, the SpaceX side, the Axiom side. Looking forward, that sets us up nicely for a SpaceX Cargo Mission 28 launch this Saturday, June 3rd at 12:35 Eastern Time out of Kennedy Space Center, and that sets us up for docking early Monday morning on June 5th. That mission will be bringing up 2 more solar arrays that will augment our power system. In total, we'll be bringing up about 7,000 pounds of research and hardware and cargo to the International Space Station, which you'll hear tomorrow at the post-launch readiness review briefing in the afternoon. With that, let me hand it back over to Gary.
Appreciate that, Joel, and thank you, everybody, for those initial remarks. We're now going to open it up for questions. So again, if you're on the phone bridge, please press *1 to make sure you enter into our queue, and we can pull you up to ask a question. Once your name is called, please remember to direct to whom you'd like to direct your question. And we expect a lot of questions, so if you find that yours has already been answered, at any time you can press *2 to withdraw it. So let's go ahead and open up our phone bridge, starting with Lauren Grush from Bloomberg.
Hi, thank you so much. I just wanted to clarify these 2 new issues that have cropped up. Just to be clear, were they present and an issue when OFT-2 was launched last year? And how come they were only found now and not in the immediate aftermath of that flight? Thank you.
So, yes. Oh, go ahead.
I could take a cut at it and then see if you have anything to add. Let's see, relative to the tape was actually present on that vehicle as well to protect the wiring on that vehicle. And so it flew last mission, as well as the existing design for the soft links. That mission landed and performed successfully. All the mission objectives were met. It was, through the flight certification process that we went in when we were looking at the system in more detail for certifying essentially the fire extinguisher, looking for flammable kind of materials, is where the PE-213 tape was found. And then for OFT-2, we did not do a complete certification of the parachute system for that flight. And what we did was we certified it to be safe to protect the public, but we didn't do the detailed look. And it was in the detailed review, doing a second look for the crewed flight tests, that we found that this one joint that Mark talked about didn't meet the required safety factors. And I'll see if you have anything else to add, Mark.
Yeah, that's a good summary, Steve. I think the only thing I would add is that, when we set the design requirements and perform the certification process, this isn't just for nominal flight. This is for sometimes several failures deep. It's for, sometimes extreme cases where you lose 1 or 2 chutes, and what does that mean to the vehicle? And so, these problems that we're talking about would affect us if we had some of those failures occur already. So under nominal conditions for OFT-1, OFT-2, they performed like they should have, and it wouldn't happen unless we had these multiple failures that we would see this failure mode come into play.
Okay, great. Thank you both. Let's move on to Jeff Faust from Space News.
Good afternoon. At the Aerospace Safety Advisory Panel meeting a week ago, the panel suggested that NASA charter an independent review of the work ahead for Starliner, given its skepticism that the certification work could be closed in time for July launch. Given this latest issue, is it time for the agency to set up something like an independent review through the NASA Engineering and Safety Center or other organization to provide a fresh set of eyes, since we seem to keep having issues like this pop up during the preparations for the mission? Thanks.
Yeah, this is Steve Stitch. I'll address that question. Yeah, we appreciate the Aerospace Safety Advisory Panel's recommendation to have perhaps have the NESC, the NASA Engineering Safety Center, take a look at the issues and have some independence. What we have decided to do within NASA is we have NASA NESC experts essentially as part of every single team that we have. In fact, the parachute team, for one, has an outstanding engineer that's a part of that team. So relative to the issues that we're talking about, we're going to have those individuals brief a panel of the Office of the Chief Engineer, Joe Pelliciotti, the head of the Chief Engineer's Office, John McManaman, the Deputy Chief Engineer, and also Tim Wilson, who's the head of the NESC. And they'll form an independent look. We use this process, and they use this process all the time. In fact, every single flight that we go fly on the NASA side in the human spaceflight arena, they are following every single issue, and they're getting briefings from the engineering team. And so they have a level of independence. They report up through the chief engineer and then up to Bob Cabana. It's a different reporting path than the program has. And so when we talk to the Office of the Administrator, talk to Bob Cabana and Ken Bowersox, the head of Space Ops Mission Directorate, they felt like this process was sound and solid. It gave an independent reporting path, and so that's what we plan to use to fulfill what the ASAP is requesting, which I think is an excellent request from the ASAP.
Thanks for the question. Let's go on to Eric Berger with Ars Technica.
Hi, thanks for having this call and being transparent about all this. Two questions. First of all, about the tape, the flammable tape. Is that on wiring inside the spacecraft, and under what circumstances might that catch fire? And then for Mark, the question I would have for you in these discussions internally at Boeing, which I know you can't fully characterize, but as you're briefing this up the chain and all the way to the CEO, was there any consideration given to walking away from Starliner at this point? Given that there's a pretty big financial road ahead in getting the spacecraft off the ground. Thanks very much.
Okay, let me start with the last question first. We are very focused on the issue, and so that's what the discussions have been. Separately, we've been talking about the future of Starliner and how we are going to move forward. Those discussions are going well and really not affected by this. We know that there's growing pains in developing a vehicle and flying a vehicle. We're really close, and this is just part of the business to have these kinds of issues. So I don't see us making those kinds of decisions anytime soon. The flammability of the tape. Can you repeat that question again so we can make sure we answer it properly?
I'm just trying to better understand the nature of this wiring harness tape that was said to be flammable. I don't quite understand that, and under what circumstances that might be an issue in flight.
Okay. Well, the tape itself is used to wrap the wire harnesses to protect it from any nicks or chafing from either flight or in-process work. We learned this during shuttle and other programs that it's good to protect your wire harnesses from that type of damage. So it's quite extensively used on the wiring harnesses inside the vehicle. When you take the back shells off, you can see the white wire harnesses, and that's why they're white, is because they're wrapped with this tape. And so the type of failure that you would have is, first of all, you got to have the right oxygen enriched environment. You have to have some kind of ignition source, and then you have to have the nick or the opportunity for this wire harness to get ignited and actually catch on fire. We've done quite a bit of testing to see how it burns, so that we can and under what power sources it burns, so that we can completely understand that. And then when we move forward towards mitigation, making sure that we prevent that from happening.
And this is Steve. I would add one thing to the wiring, right? You'd have to have some sort of failure, and one of the things that we're doing is looking at the wiring to make sure that it's all installed properly. We've had NASA teams walk down the vehicle, and so the only way to get that wiring to be flammable, it's not normally the tape is on the wiring and there's no concern for the wire carrying the current. It would have to have an exposed conductor in the wire that then shorts to some area, and then that could potentially cause an ignition event if the circuit protection didn't trip off the wiring. So it's kind of a failure scenario, but we have to go work through it, as Mark said. And then to address the second question, NASA desperately needs a second provider for crew transportation. We are very excited of having Boeing get certified and fly our crews to station. Our ultimate goal is to have one SpaceX and one Boeing flight per year to rotate our crews to station. And so we support Boeing, and we're doing everything we can during the investigation of each of these issues and trying to get to flight as soon as we can when it's safe to do so.
All right, thank you for the question. Let's move on to Chris Davenport with the Washington Post.
Hi, thanks for doing this. Two quick ones for Mark. In terms of the parachutes, I believe you get those from Airborne Systems. So I'm just wondering who's responsible for the design that led to this problem. Is that an Airborne problem or is that a Boeing one? And then to follow up on Eric's question, because in the past when you've been asked about the future of Starliner and commitment to the program, I feel like Boeing has been steadfast and adamant about Boeing's commitment to the program and to providing this, but you didn't say that. You said that you're having discussions about the future of Starliner and that those conversations are ongoing and going well, but you seem to me at least to leave the door open that you might quit the program. Is that what you meant to say?
Okay, I'll start with the last question first again then. No, that is not what I meant to say. I'm sorry for conveying that thought. We have, to fly Starliner, to continue to fly Starliner, we have to make some decisions on which launch vehicle we're going to use. We run out of atlases. There's an opportunity to modify the service module. If we reach a certain flight rate, we will need to build more crew modules. Those are the discussions that we're having with our management on, the types of investment that it takes, the customers that are currently out there that we would utilize to make the business case close. Those are the types of discussions that we're having. How do we move forward with those variables? So I didn't mean to imply that we're backing off our commitment. We're still committed. Now, the second part of the question was, who's responsible for the design? So we do use Airborne for the design of the parachutes, as other providers do. I don't want to imply that this is the fault of our supplier. We all have a hand in this. These tests were run many years ago. We reviewed those results. We missed those results. And this could have been caught sooner. And again, part of the process now is to review that data. It was caught in this final review that these entries were made incorrectly, and so we all take responsibility for that error, and we'll work together as we have been for the past week and in the past several years, in making sure the parachute system is safe for flight.
Okay, let's go on to Marcia Dunn with Associated Press.
Yes, hi. Getting back to the tape, how much tape in the capsule are we talking about? Dozens of feet, hundreds of feet? And to me, it sort of sounds like a tougher fix than the parachute lines, digging out all these wire harnesses and unwrapping tight tape. Is Is that really the harder of the two problems here? And lastly, is a launch this year feasible in your minds, given all the work ahead? Thanks.
Okay, so there is a lot of tape on the wire harness. As you can imagine, how many wire harnesses that we have in the vehicle. I wouldn't guess on how many feet, but it's certainly hundreds of feet of tape that's wrapped around these wire harnesses. So, we've talked about, again, the problem is relatively fresh, but we've talked about solutions to this, and I highly unlikely that we would go in and cut this tape off. It would probably cause more damage or potential damage than we're trying to solve for. So we're looking at solutions that would provide for potentially another type of wrapping over the existing tape in the most vulnerable areas that reduces the risk of a fire hazard.
And is a launch this year feasible, do you think?
Yeah, the second part of that question, I think it's feasible, but I certainly don't want to commit to any dates or timeframes until we spend the next several days understanding what we need to go do to solve both these problems.
Thanks for the question. Let's go on to Irene Klotz, Aviation Week.
Hi, thanks very much. You partly addressed part of the question, which is I was wondering if the flammability is an issue wherever there is tape or only in particular areas. And then I also was wondering how many Atlas V ULA has committed at this point to Boeing for Starliners.
Let me try to address the flammability, and then I'll let Mark answer the Atlas V question. The flammability, we do know some of the wiring is, even though the tape itself is flammable, and it really isn't the tape itself. There's kind of a fiberglass layer on the tape. It's the adhesive that is the flammable part of the tape. But we know some wiring, just doesn't have enough energy. Essentially, if it had a little nick or it was able to short, it just doesn't have enough energy to. We've done testing, so it wouldn't cause combustion of that tape. So it's only some of the other wires that have enough power running through them that would cause potential combustion. And again, it's a failure scenario where you would have a nick in the tape. So, as Mark said, we've got to kind of go work through that, Irene, totally, and see what we've got to go do to mitigate that. And then I'll let Mark answer the question relative to the number of Atlases.
Yeah, so on the number of Atlases, of course, we have the Atlas for CFT, and then we have the Atlases set aside for PCM 1 through 6.
All right, let's go on to Joey Roulette, Reuters.
Thanks. Question for Mark. When specifically, or as specific as you can remember, did Boeing discover each of these issues, and is Boeing bearing the cost for the investigations and the fixes into them? And Steve, I just want to be a little clear. The reporting and review process that you described with the chief engineer and the NESC embeds in the Boeing investigation, is that a new process, a new independent process that was responsive to the recent ASAP recommendation? Thanks.
Yeah, I'll answer the last question first, and then let Mark answer the other questions. But yeah, I would say it's not really a new process. Every flight we have NESC engineers embedded, and then our chief engineer team essentially briefs that group that I talked about, the Office of the Chief Engineer, the Chief Engineer for the agency, Joe Pellicciati, and Tim Wilson, the head of the NESC, on all the issues. So we felt like this was the best process to use because it's one that we have used for issues for other flights, and this really kind of rolls up into our flight readiness process. So it's really not anything different than we've done in the past. And we think there's a level of independence. The thing that we like about the process is we have engineers that are knowledgeable about the systems. Really, the NESC is embedded in all of our teams, as I said, parachutes, wiring, materials, and so they can go, are smart enough and knowledgeable enough about the systems to make their own judgments and then roll those up to a different different reporting path than it would be up through the program.
Gotcha. I guess my question is it a new process that you're implementing for these specific Boeing investigations? And if not, just to follow up on Jeff's question, do you think it's time to do something new for those investigations following the ASAP recommendation?
Yeah, I would say the process is not new. We're going to take a little extra time and extra focus. I think the one difference is that here, the problem that we talked about with the soft link on the parachutes and the P213 tape were found relatively late. I don't have exact dates of when we first identified the soft link issue. It's probably a matter of a week or two old, and the same thing with the tape. These are not these are weeks old, not months old, right? So that's the difference here. And so we're going to have them do a little bit of a special deep dive, if you will, on these issues. Of course, as Mark talked about, modifications to that soft link, the team would be involved in any kind of modifications in the testing program associated with that. So.
Thanks. And then the question for Mark, if you can remember with specificity the dates of those issues and if Boeing is bearing the cost for the fixes into them. Thanks.
Yeah, these issues were discovered leading up to the Memorial Day weekend, and as soon as we worked it over the weekend, as soon as we got back on Tuesday with the majority of the team, we continued to work it. So again, they're relatively fresh. And as far as the cost, we're still working under a fixed firm price contract, and we're working under those arrangements. So we'll continue to bear the costs.
I appreciate the detailed response. For those on the line, we do have a number of folks that are wanting to ask questions, so I'll just send out a reminder. Just if you can limit to one question, and then if you want to ask another question, just re-enter into the queue. But we only have 30 minutes left, and I do want to make sure we get to everybody so everybody has a chance to ask a question. So next on the line is Bill Harbwood with CBS News.
Hey, thank you very much. I think this is for Mark. How many soft links are used on the spacecraft, and how many suspension lines are attached to each one? And then what's the actual failure mode? In other words, what would happen if one of the soft links failed during or after inflation? I mean, I assume that gang of suspension lines would come loose, but would the chute still work? So any details about the failure mode? Thanks.
All right, I'll reach to Steve for some help here, but there's I believe eight of these soft links around the parachute lines that go up. This failure mode, first of all, these are rated as safety critical. So, the normal factors of safety are normally lower than 2, but these systems, we've got a 2.0 factor of safety requirement. So obviously we want to get back to that with the work that we're going to do in front of us. And so the failure modes that we're protecting against is, I believe, Steve, you can help me here, I believe it's one chute out, so where you only have 2 chutes left, and that's where, this link would be susceptible to excessive loads that we could see a failure.
Yeah, Bill, Mark said it really well, right? It's the stressing cases would be, we designed the parachute systems to be able to tolerate one chute out for landing. And there's 80 on a main parachute, for example. There's 80 suspension lines. They go 10 of them go into each of these things called a bridle, and that's where the soft links are essentially in that bridle. I think there's 24 of these soft links per main canopy, or maybe it's 8 per main canopy, and then 24 total. So, and as Mark said, it's what's called a safety critical joint. So it's supposed to have a factor of safety of 2 because it's a soft good, and there's variability in how you manufacture soft goods. So the factor of safety is not there at 2, and so that's why we're looking at, as Mark talked about, modifications.
But this would only be an issue if you already had a shootout. Is that what we're saying? And then one failed. Is that what you're saying?
Yeah, you'd have to have a parachute out, and then you overloaded one of these soft links, and
Got it.
Yeah.
Thanks.
So, and that's why we landed OFT2 safely with all three chutes out, and the soft links performed nominally, and they didn't exceed the load capability of the soft links. So, but it's a safety critical system, and I believe on the main canopy, I think there's 4 safety critical systems. This is one of them.
Thanks.
All right, next is Micah Maidenberg with the Wall Street Journal.
Hey there. Hey, Mark. I'd like to follow up on Eric and Chris's questions earlier. You said that the company is committed to Commercial Crew and Starliner, but, have you or colleagues just in the course of discussing Starliner and its future ever discussed at all, dropping out of the program? Has that topic been broached just at any point in time? Thanks.
No, not serious discussions about that. We have to. We're really focused on the future and what it takes to, first of all, get certified. That's so then CFT is right in front of that. Then we have to focus on meeting our commitments to NASA, which is 1 through 3 and then 4 through 6. And the reason that we're looking at the future of Starliner now is because there are some pretty long lead decisions that have to be made. For example, if we're going to fly over twice a year, there's 4 to 4.5 year lead time on building additional crew modules. So those kinds of decisions need to be made now. If we're going to do any modifications to the service module, those kinds of decisions and testing need to be done now. And we are actually doing some testing on the propulsion system in preparation for those potential modifications. Moving to another launch vehicle is a big deal. So that launch vehicle integration needs to start now, and we've actually been in discussions with some of the providers already to put those contracts in place. So that's really where our focus has been.
Yeah, and at least on the NASA side, there's an unwavering commitment to Starliner and to having a second crew transportation system. I think we've seen times, all of us have in the past, where we've had failures with the launch vehicles or a problem where the fleet has stood down. And, Joel's science mission on ISS really needs the crew on orbit. And so we would like to get, as soon as we're safe to go fly the crew flight test, get that mission flown, get the data from that flight, get into certification, and then get into the post-certification missions that Mark talked about. And, we both Joel and I are depending on Boeing and the team to get the vehicle certified and ready to fly those flights. And so all of our planning lays in Starliner.
All right, next is Tim Fernholt, of course.
Hi there. Thank you for taking my question. For both, I guess, Steve and Mark, I'm just curious how you feel, how your confidence is with the engineering and safety culture at Boeing right now. Has there been enough change since OFT1? I know the communication and transparency here has been great, but I guess it does feel like we're seeing these things stack up. And so I'm curious, is there a thought of broader review of just of how you guys are doing business?
Yeah, I'll start, and then we'll let Mark add anything to it. I mean, I have seen a tremendous change in the Boeing culture since the first orbit flight test, and it's a testament to all the changes that the Boeing company has made. The leadership from John Vollmer and Mark have been extraordinary. I think the work that we have been doing to get us to crewed flight has been very thorough and comprehensive. Some of the things that we're seeing here were actually things that were done many years ago, right? The parachute system has not changed. There has been no design changes and significant design changes in many years. And so in some cases now we're finding things that were actually there from many years ago. And so I wouldn't go indict anything on the NASA or the Boeing safety process because we have these late findings. That just now we are getting to the reviews of some systems like the parachutes in detail, and all the reports that come from Boeing and the airborne systems And so we're finding things that were there for perhaps many years ago, and we've got to go now address them and resolve them. So I'm seeing us find things and make changes to the vehicle and do additional testing and engineering where we need to, and that's what's required to go fly safely. And I'll see if Mark has anything to add.
Yeah, thanks, Steve. I have a kind of my view is that the safety culture has always been strong. We are finding things now. That's a testament to the process. The process is catching things. It could be questionable, should we be catching these types of things this late? And that might be because, there was a certain sense of optimism when some of the designs were done, some of the processes were created many years ago, and they led to some of these things kind of creeping their way through the system and had us catch them as late as we are. So, to summarize, I think the safety culture is strong, has been strong. I think, we're probably more transparent now with the way we're working with the customer and you all. That's all positive. John started that, and I've been able to pick it up. And, the process is catching these things, and we'll continue to, do these thorough reviews and catch things and talk about them and fix them.
All right, next is Tarek Malik, Space.com.
Yes, hello, thank you. My question is for Mark, just to understand the nature of the soft link issue on the parachutes themselves. I mean, how integrated are these soft links in the chutes themselves? I mean, in terms of a fix, are you looking at a full parachute redesign then, or is it just the soft link redesign that could lead to a shorter turnaround in terms of the approach to the first crewed flight? I'm just trying to understand how that would work for this approach here. Thanks.
Yeah, that's a good question. We have, last week when this problem popped up, we peeled a couple folks off of the team and said, hey, you guys need to start looking at what we would do if it doesn't pan out for CFT with the analysis and we can't fly what we have. And also, we need to get busy because for the long term, we need to correct this problem. So the team has been off looking at these soft links. They're actually a fairly small segment of those long lines that go from the vehicle all the way up to the chutes themselves. And what will have to happen is the chutes will have to be removed, and then we'll have to determine which chutes we'll use next, and we'll incorporate a modified soft link that has the right load-bearing characteristics, and then repack those chutes and use them for the next flight. So it is just really concentrated. At this point, we believe it's very concentrated on just those soft links.
All right, next is David Denault about Space Today.
Good afternoon. My question pertains to the spaceport. American spaceport's getting a little busy as you look at the calendar. So Steve and Joe, walk us through a step-by-step process in the event that we could possibly launch Starliner this year. So what it would take today to go through that process, step by step, please.
Hey, Steve, I can start, and then you can add. From an ISS standpoint, our job is the priority is to maintain these crew rotations. And so we generally fly expeditions about 6 months at a time. And so, as you know, we change those out today on SpaceX and on Soyuz. So those would be the priorities. And then after that, we would look for a home for the Boeing mission. Have a little more flexibility on the cargo missions. And so we would work the cargo missions as secondary to this Boeing mission. You also have to look at the launch pad. Not only does the SpaceX launch missions to ISS, but they have other customers as well, and we would just have to work with them. But in the past, human spaceflight has been the priority, and we've worked well together. So let me ask Steve if you want to add anything.
Let's see, Joel, thank you. Yeah, I think, you talked about from an ISS manifest perspective, we have the crew rotation coming up. If you just look at this calendar year, for example, in mid-August, and then the Soyuz rotation in September. And so we go find those windows right around those operations. Those are the only ones that Joel said are really high priority right now, because we have vehicles and crews that need to rotate back down. And then, so there's a window, in the fall to go find an opportunity should we be ready. And then essentially on the Boeing and NASA CC commercial crew side, we have to lay out what work we need to go execute on the vehicles relative to the tape, and then the parachutes, as Mark talked about, the soft link modifications. How long will that take? And then when will those be complete, such that the parachutes can be reinstalled in the vehicle? The ascent cover has to be removed to get to the parachutes, as does the forward heat shield. And then we would lay all that out, right? And then once they're reinstalled, there's a sequence of tests that happen, and the fueling operations that we talked about for a July 21st launch. Mark alluded to, mid-June we had to fuel the service module. So we would lay out that schedule and then see what the launch date results. And as Mark said earlier, we've got to go lay out the work required on the tape and the soft link, which we haven't had a chance to do yet, because we're focused a little bit on, hey, how significant is the problem, and is it something that we have to go address before we go fly?
So presumably, if all of that came together, you're saying that there's a possibility of a window in the fall.
Yeah, I think from an ISS perspective, there definitely is a window in the fall, as Joel talked about, and then we would have to look, does the schedule line up to support that? And I don't think Mark nor I are ready to commit to any date, but there would be a window from an ISS traffic perspective in the fall.
Thank you very much.
Next, we'll go to Michael Roston, New York Times.
Yeah, thank you for taking my questions. I think this is probably for Mark Nappy. You mentioned something about lifetime expiration issues with items aboard the Starliner, and I was wondering if you could speak more to some of those and whether you think that they would have any implications toward further postponing the flight once these issues with the parachute and with the tape are resolved. Thank you.
Yeah, well, for the hardware on the hardware on the vehicle, there are time and life cycle requirements. For example, seals have a life before they need to be replaced. So, when we set launch dates, we go through that time life cycle set of requirements and make sure that we have nothing expiring on the vehicle. And since we'll be moving this one out a few months, we will have to do that review again and determine if there's anything that needs to be replaced or if there's any special testing that we need to go do in order to make sure that that hardware is still good. And that's a pretty normal process that we run through when we launch these vehicles, and all the providers do the same thing.
Thank you.
All right, thanks. Let's go to Andrea Leinfelder, Houston Chronicle.
Hi, I was hoping just to get a little bit of a layman's explanation on what lower failure load means. I know you were explaining earlier that if one chute goes out, it could overload, the soft links could be overloaded, but is it fair to say that a lower failure load means there needs to be less stress on these soft links to fail, or they're more likely to fail? Can you just kind of dumb that down for us? Thank you.
Let's see, I'll try and then see if Mark has anything to add. So if you think about the capsule has a certain weight, right? When you have three parachutes, each of those three parachutes is taking some amount of the load, right, or some amount of the weight. So it's essentially, say it's carrying a third of the weight. So in a case where a parachute were not to deploy properly or have an issue, and this is really stemming back all the way to the Apollo days where those capsule, Apollo had three parachutes and was designed to land with 2. And so the remaining 2 canopies would be stressed more And so in this case, the soft link, there's 80 suspension lines on a main. Each of those soft links would carry a little bit more load because each suspension line going all the way up to the suspension line is the 80 lines that go up to the material of the canopy, essentially the ring of the canopy. Each of those is taking a little bit more, carrying a little bit more weight, transferring into the soft load, which then transfers that load down into the what's called a line that goes into the capsule, attached to the capsule itself. So there's a little bit more stress that those soft links would endure if one of the chutes didn't deploy. Does that make sense?
Yeah, that does make sense. And so basically, it'd be too much stress, you guys have discovered.
Correct. And you know, we have a factor of safety for unknowns. And so when we say we need more factor safety, you don't want to design a system to carry just the load that it would see. It needs to have a little bit, because there might be a little bit of uncertainty on the load and a little uncertainty on the joint. So that's why everything is designed with a factor of safety, including the bridges that you drive over and other buildings that you're in. Those have factors of safety. In aerospace, as Mark alluded to, most of the time factor of safety for things like the wing is 1.4, which means you could essentially tolerate a 40% error in the material or the load that it sees. And in parachutes, most of the factor of safety is 1.6, which means it needs to handle 60% more load. And in these safety critical joints, it really needs to handle up to twice the load, essentially. So if that makes sense.
Thanks for the question. Let's go on to Michael Sheets, CNBC.
Hi there. My question is for Mark. Back in October, Boeing had increased its total costs and charges associated with the Starliner program to $883 million to date, and that was 7 months ago. So at this point, how many additional costs has Boeing accrued in regards to Starliner delays and further development? Thanks.
So, you know, when we do our cost estimates, it's estimated complete for the program. So that estimate was, you know, what it's going to take to complete the program. You know, this problem is too new to determine if this is going to require additional expenses or not. So I really can't comment on, you know, what that means to us at this point.
Mark, but before this issue, there hadn't been any more costs associated with the program since October?
Yeah, I think we'd have to get back with you to understand your question a little bit better and maybe give you some more precise data.
All right, let's move on to Gina Sinceri, ABC News.
I have a math question. How much tape are we talking about? 1 yard, 2 yards? Do you have that kind of measurement? Do you have to replace?
Yeah, I think
Or cover. Your plan is to cover it, but are we talking several hundred feet? What are we talking about here?
Yes, it's on a great deal of the wiring that we have on the vehicle. So I would have to get the exact estimate on how much line it covers, but it's several hundred feet or more.
All right, let's go to Ken Kramer next with Space Up Close.
Hi, thank you for taking my question and doing this. Back to the parachutes. If you have to replace these links with something stronger, will you have to do new parachute drop tests to confirm all of that? Thanks.
I think that's in the forward plan to determine if that's necessary. Well, obviously, that'll be a decision that we'll make with our supplier, Airborne, and NASA, and that's TBD, and we'll make that decision here in the next week.
Well, is it likely?
I still really don't want to speculate. I think we need to leave it up to the experts to determine if that's necessary.
All right. Thank you.
Next is Sophie Sanchez, Cosmic Chicago.
Hi, I had a question for Steve Stitch.
it was mentioned that the soft link failures were kind of noticed during OFT2. During the software issues that were noticed previously, NASA mentioned having more oversight and working closer with Boeing. How do you get from OFT2 to now without NASA stepping in, working a little closer, noticing these issues? We're a month out from a potential, well, we were a month out from our potential crewed flight. I'd just like to get some more details on what kind of oversight was happening and how this was missed or just not reviewed. Thank you.
Yeah, it's a good question. I would say NASA has tremendous oversight in the parachute system, and this was sort of caught by the joint team reviewing the data provided by Airborne on the details of the joints. We went through that data recently, and that's where we, as Mark talked about, uncover the joint efficiency error. Some of the testing that was done to produce the original joint efficiency tests were done many, many years ago, and so Airborne went in and repeated the testing in a little different manner and found the joint efficiency error. So I think we have good coverage across the vehicle. In fact, we have jointly executed a number of parachute tests with the Boeing team. We are going to execute a ground test in a few weeks of the forward heat shield parachute, and that's really Boeing and NASA working side by side. So I feel like we have good coverage of all the issues, and we're working them side by side with Boeing. We understand the tape issue. In fact, NASA has performed the flammability testing. That is all done at the NASA White Sands test facility. The flammability experts in the NASA in the agency are at White Sands. We've been using those experts. And then the certification process is very thorough and comprehensive. To get to flight, we have to approve every single one of our requirements. In some cases, if there's any areas that have a bit of an elevated risk, those have to come to me to approve. I have to sign off on every one of those, as does our technical authority, engineering, safety, and mission assurance, flight ops, and our health and medical. So I believe we have good coverage in terms of the hazard reports. NASA reviews every single hazard report, line by line. We look at every single cause in the hazard report. We look at all the controls. So I wouldn't gather from this that this is a lack of NASA oversight or penetration. These are just late emerging issues, unfortunately, relative to the launch date that was, a couple months in the future, so, or a month and a half in the future now, let's just say. So.
Thanks, Steve, and thanks everybody for the questions. We do have a couple of extra questions in the queue, but we're going to go ahead and wrap up for today. If we didn't get to answer your question, you can go ahead and send those questions to the media contacts that were in the press advisory, and we'll try to get back to you as soon as we possibly can. So thanks to everyone that submitted questions, and thanks again to our briefers for taking the time to discuss the crew flight test. You can find the latest on this mission and other commercial crew updates at nasa.gov/commercial crew. So thanks everyone again for joining us. That'll wrap up today's briefing.
Thank you. That does conclude today's conference. Thank you all for participating. You may disconnect at this time.